Good morning, good morning. So we're going to start on bone tissue. I believe you just have your test over the integumentary system. So let's look at bones. Let me get this out of my way. And let me enlarge this so I can see it a little better. And here we go. There are 6 major functions of bones. They support, giving structure to the framework so I can sit here and talk to you. They protect us. I can fall and knock my head and usually not hurt anything, or somebody can hit me in the chest. My heart continues to beat. It assists in movement, that I can do all those anatomical things and movements. And it also stores minerals. So it maintains homeostasis. Remember, homeostasis means to keep me in a good balance, that I'm not too much or not too little, I'm just right. And it stores calcium, phosphorus, and magnesium. Then our blood cell promotion is hemo, meaning blood, hemopoiesis. Poiesis means to produce. So hemopoiesis or hematopoiesis, and hemato also means blood. So hemo or hemato means blood, and it makes not just red blood cells, or it makes all the blood cells, red, white, and platelets. So let's learn names for them. Red blood cells are erythrocytes. White blood cells are leukocytes, and platelets are thrombocytes. So thrombocytes, erythrocytes, and leukocytes. And this occurs in spongy bone. Now, we've learned about spongy bone in tissues. Spongy bones at the ends, the epiphysis of a long bone. And then we talked about triglycerides. Triglycerides are fat, and we store that in the shaft of the bone, and that is called the diaphysis. So let's catch up with our learning guide. And 1 is structure. 2 is protection. 3, make sure you understand that it assists with movement. It doesn't create movement. Nerves create the movement, nerves and muscles, but it assists in movement. The next one is mineral storage, and you need to know the minerals. And so we're going to put calcium, which is Ca, phosphorus, which is P. Of course, let me move this so we can get it in the right location. P, and magnesium is Mg. And we know that from chapter 2. Then we have number 5. And number 5 is blood cell production. And we need to know that is hemopoiesis or hematopoiesis. So it is, they both are the same thing. It just is 2 words for the same thing, which you should be used to in anatomy. And then six is triglyceride or fat storage. So those are the 6 functions. We probably know the first 3: structure, protection, movement, assist with movement. Then we get into the kind of the gray area, the other 3, the mineral storage of calcium, phosphorus, magnesium, the production of blood cells, hemato or hemopoiesis, and then triglyceride storage in the diathesis, and triglycerides are fat. What is hemopoiesis and where does it occur? So hemopoiesis is the production of blood cells. That includes platelets, red blood cells, and white blood cells. It occurs in spongy bone. Yeah, spongy bone. In spongy bone, it occurs in specifically the red bone marrow of spongy bone. Now, spongy bone occurs at the epiphysis of long bones or in between flat bones. And what's another name for hemopoiesis? So hemopoiesis equals hematopoiesis. It's the same thing. And then it wants to know, what's the difference between red and yellow bone marrow? Good question. So let's start with red bone marrow. Red bone marrow is found in spongy bone and does hemo or hematopoiesis. And let's be even more specific. Yeah, that's good. That's good. It's found in red bone marrow. And we should know that spongy bone is found at the ends of long bones and in between the flat bones. So then let's talk about yellow bone marrow. Let's change the color on that so that it maybe sticks out a little bit. I won't make it yellow because it's hard to see. So yellow bone marrow is found in the shaft of a long bone called the medullary cavity. And it is the storage of triglycerides. Now remember, triglycerides are the storage form of our fat so that we have it for energy. So we should say that triglycerides is a storage of energy for the body. All right, so now we know the difference between red bone marrow and yellow bone marrow, and triglycerides versus homeostasis. All right, I'll give you a little time to write that out, and that takes us then to this long bone picture. And here we can see spongy bone. Spongy bone is what we see when we buy pork chops or T-bones, or if the cartilage falls off the ribs that we might be eating, and you look down inside and it's got threads to it, it's porous, it's not solid. That's where hemo or hematopoiesis occurs, where this solid bone, this is the shaft of the bone called the diaphysis. The shaft of the bone is where yellow bone marrow is stored. And that is in round steak bone that we see. A round steak has solid bone around it with this white stuff at the store until we cook it, it turns yellow. And that's what is yellow bone marrow, the storage of fat. So then let's study the parts and pieces of bone. So let's clear my screen. And let's move this up so that we're fresh with the next picture. And then the next thing it wants us to do is to draw a long bone. So let's make it. So here's my long bone. Kind of a poor looking long bone, but it's a long bone. And it says, please label the following parts of the bone. So let's do that. The proximal end, closest into the center. So we'll just say this is my humerus, and this part right here is closest to my shoulder. So we're going to call this the proximal. Epiphysis. And epiphysis is the end of the bone. So that makes this the distal epiphysis. Distal epiphysis. And this long hollow place is called the diaphysis, which is the shaft of the bone. Now, this neck part, where we go from the diaphysis out to the epiphysis, that's called the metaphysis. Metaphysis. And then we got to draw some other parts in. So let me go to blue to get the articular cartilage. So at the ends of the bones, we learned that there is articular cartilage. Remember, in tissues, we learned about cartilage. And at the ends of the bone is cartilage, hyaline cartilage, to absorb the shock. And then we also need to draw a line in here. So let's get, I think I want to keep it blue. So erase this pink because I don't want pink. Control Z. Let's do blue. So I'm still on erase. So here is the line. And let's see what else. Epiphyseal plate, articular cartilage, periosteum. Medullary cavity, so I need to make a cavity of this. So we'll put in the spongy bone here. And this is a solid bone, so we need to color this in. Medullary cavity and then endosteum, so I got to get back to orange. Orange doesn't stand out. Pink might stand out. Well, but yeah. So right along the inside of that. All right, so let's go back to labeling. So we got the metaphysis, which is the neck. So let me put that in parentheses, the neck. Oops, come on. The neck. And the epiphyseal plate, that's that blue line. So the epiphyseal plate. And then articular cartilage. Articular cartilage. And we got it down here too. So articular cartilage. We have epiphyseal plate. Epiphyseal plate. We have the medullary cavity. Medullary cavity. I'm going to put endosteum in yellow so we know what it is. Oops, medullary cavity is, we'll keep it in green. And we'll put endosteum in yellow. And osteum. And then in orange. Oh, I want to keep that yellow. Oh, come on. And then let's over here put endosteum in orange. Peri. Let's put, come on, peri. Osteum. All right, so let's connect the boxes. Articular cartilage is blue, so let's draw arrows. I want blue. All right, so here is blue and here is blue. Those are called articular cartilage. The epiphyseal plate is this little round area but in the metaphysis. And we know the metaphysis is the neck of the bone. So this neck area is the metaphysis. The diaphysis is the shaft of the bone. The distal and proximal end of the bones are called epiphysis. The medullary cavity is the center of this bone. The endosteum is a lining of the medullary cavity. And the periosteum, which is orange, is the covering on the outside of the bone. I think I have everything labeled. So now let's look more in depth. So here we have the proximal and distal epiphysis. Epiphysis is the ends of long bone, and the diaphysis is the shaft of long bone. The metaphysis is this neck area as it goes from the diaphysis to the epiphysis. It's the neck area. And in the metaphysis is this epiphyseal plate. And over here, because it's color of bone, it is called the epiphyseal line. The epiphyseal line. So when it's bone, growth has stopped. But when it's a plate still made of cartilage, and I'm going to say not 21, but 25. So let's change this to not 21. Let's put 25. So sometime between the age of 18 and 25, the bone stops growing in length, and the epiphyseal cartilage, or the epiphyseal plate, which is made up of cartilage, is still growing in length because it puts new cells on the diaphysis side, so it grows longer. And again, the new cells are not on the epiphyseal plate, but on the epiphyseal side, but on the diaphysis side. So the diaphysis gets longer. But the neck portion is called the metaphysis. Metaphysis. So let me erase this 25, but you should know it's 25, not 21. All right, that being said, let's go to the next slide. The articular cartilage is at the ends, and the ends are called epiphysis. The ends of bone. Ends of bone. So the ends of the bones are called epiphysis. Epiphysis. All right. Then this lining, wherever the cartilage is not, is called the periosteum. You can see just a little piece of it, periosteum. Sometimes when you get chicken legs and it's been cooked and you pull that little thin bone off of it, for lack of better terms, let's say it's the fibula. When you pull that off, sometimes it pulls off this little flap up where it attaches, and that little flap is called the periosteum, so that you see into the spongy bone. You see porous bone that has little holes in it. And this periosteum is dense, irregular connective tissue. So that means it can be pulled in many different directions because it's irregular. And this is where your tendons and your ligaments will attach in. Now, keep in mind that bone-forming cells of the periosteum enables the bone to grow in thickness. So the epiphyseal plate allows it to grow in length. But the epiphysis, the periosteum, allows it to grow in width because it puts new bone cells down on the diaphysis and the metaphysis of the bone. Now, this dense connective tissue called periosteum protects the bone. And because it does have new producing bone cells near it, it also helps in fracture repair. So if I ever break a bone, it helps in the healing process of putting the bone back together. It also allows for blood vessels and nerves to come into the bone without getting sheared off every time we move. And that helps in the nutrition of the bone. So the periosteum is very highly supplied in blood vessels and in nerve fibers. So we feel when something happens to our bone. Now, what holds that periosteum so tightly to the bone? That is called Sharpey's fibers. Sharpey's fibers, the little spot welds that hold it directly to the bone. Sharpey's fibers. And then we get to in the diaphysis, the shaft of the bone, it's hollow. And the type of bone is different. This is compact bone, solid bone. On the ends, it is spongy bone. And this is called red bone marrow. Because it's red, it looks like blood, because that's where hemo or hematopoiesis occurs. But in the medullary cavity, the center of the diaphysis, this is where triglyceride storage occurs, the yellow bone marrow. Now, in kids, they're still trying to convert the red bone marrow to yellow bone marrow. So sometimes there is still spongy bone in the diaphysis of the kid. And then lining this medullary cavity is the same type of dense, irregular connective tissue on the inside, lining the cavity. And that is called the endosteum. It's just a membrane that lines the medullary cavity that separates the triglyceride storage, the yellow bone marrow, from the bone. So let me clear off this slide and let's move to this question. The question wants to know, what is the difference between an epiphyseal line versus epiphyseal plate? So let's start with the epiphyseal plate. The epiphyseal plate is in the metaphysis, the neck of where the diaphysis, the shaft of the bone, goes into the epiphysis. So it's in the metaphysis. It is cartilage. And this is where new bone cells are produced to make the produced, let me add one more thing to this, produced on the diaphysis side to make the long bone longer. That's the epiphyseal plate. That's what it does. And it usually changes to the epiphyseal line, meaning it calcifies around the age of 18 to 25. So let's go epiphyseal line is calcified epiphyseal plate where growth in length of the diaphysis has stopped. Let's change the color so that we can see that they're two different things. All right, so we know the epiphyseal plate. We have not become calcified, meaning solid bone. And we can still extend the diaphysis or increase the length of the bone. And that happens when kids keep growing, that they grow 1 to 2 inches, usually in their teenage years, in 6 months to a year. It's amazing. Right, so that being said, what is the purpose of the epiphyseal plate? Okay, so we did epiphyseal plate in green, so let's go back to green. The purpose of the epiphyseal plate is to increase the length of the diaphysis which means the length of the bone. So the individual can grow in height. So the epiphyseal plate allows the increase in length of the bone, which allows the increase in the height of the person. So the next question is, what is the medullary cavity? So I'm a little ahead of myself. Let's go back and let's put in what the medullary cavity is. So let's go to, I think I did medullary cavity, and no, that was the endosteum. So let's put the medullary cavity in red. Oh, I guess first question I better answer is blue, the articular cartilage. What is the function of the articular cartilage? So let's get up to the articular cartilage. And let's go back into this. So we know that the articular cartilage is found at the ends or the epiphysis of bones. It is a thin layer of hyaline cartilage Hyaline cartilage, you should think of costal, articular. So this is the articular part of hyaline cartilage covering the epiphysis. Oops, that should be a Y. Where long bones form a joint, and a joint is where bones come together. And the purpose, it reduces friction, meaning as my bones rub together, my knee does this, it reduces the friction. It improves the fit of the bones at the joint. And it absorbs the shock at freely movable joints. So every time I take a step, my bones come together and it absorbs that shock. So the articular cartilage does a lot. That then takes us to the medullary cavity. So we'll go down past the periosteum and we'll go to the medullary cavity. And we didn't do medullary cavity before in a color. So I'm just going to make it, we'll make it black. So let me change the color to black and let's put that in there. Medullary cavity is found in the diaphysis of a bone. Let me extend this so we don't end up like we did up above. It contains the yellow bone marrow. Again, that is triglyceride storage in adults. But in children, it still contains spongy bone. So this is the site in kids of hemo or hematopoiesis. Hemo or hematopoiesis in kids, but in adults, it's our triglyceride storage. And the endosteum and periosteum are linings that hold the blood vessels going into the bone so they don't get sheared off, holds the nerves so that they can easily pass. All right, so let me take this off so we can go to the next slide. And we know that bones, the tissue, bones are osseous. So anytime you see os, O-S-S, or osteo, O-S-T-O, that means bone. So bones are made up of 25% water, which is kind of hard to believe. But that is, they're not like the skeleton that we see after the water has drained out. 20%, 25% collagen fibers. Remember, collagen fibers are the steel girders that have some flexibility. and 50% mineral salts. That's what makes it hard, those mineral salts. And the mineral salts, the most abundant type of mineral salt is calcium phosphate. So if you remember, we go back to the very first slide, the 6 major functions of bone: store to structure, to protect, to assist in movement. And then we did mineral homeostasis. And we said it was calcium and phosphorus, so that's phosphate, and magnesium. So it kind of makes sense that this mineral storage would be calcium and phosphorus. And the other type of mineral salt is calcium magnesium magnate. And that is what forms the hardness of our bone. So the calcification, that is a new term, calcification is the process of laying down the calcium phosphate and calcium magnate, magnesium, to ossify, and ossify is a new word, to harden the bone. So let's talk about the histology of bone. So we're going to start with the osteoprogenitor cell. And some people will call that osteogenic cell. So let me clear our slide. Let me move our slide up so that we can get to the typing in it. And let me add so the function of the osteogenic cell is to develop into an osteo meaning bone again, osteoblast. And an osteoblast is an immature bone cell. So I call it a baby bone cell. Kind of makes sense, immature. Osteoblast, B for baby. An osteocyte is a mature bone cell. So now let's see what the functions are. So let's change this to green. Oop, I want that to stay black yet. So osteogenic cells, we know that it develops into osteoblasts. We know that osteoblasts form, I want to change that to green, form bones extracellular matrix. Okay, remember we talked about the extracellular matrix, which we said was the protein fibers and the ground substance. So the extracellular matrix is the protein fibers and the ground substance. And that's what the osteoblast forms. Now the osteocytes maintain the bone tissue. Maintain bone tissue. And then we should come over here. I've got to stop sharing here. There we go. And first, the osteogenic cell is produced and it develops into the osteoblast. The osteoblast forms the extracellular matrix, the protein fibers, and the ground substance. And it develops into an osteocyte, but totally unrelated to it is the osteoclast. And I call that the Pac-Man of bone. So it's the Pac-Man of bone because its purpose, let me change here, the purpose of, or the function, so the function in resorption, it sounds like reabsorption, but since it wasn't already in the bloodstream, it's called resorption, meaning it breaks down bone and we put the calcium and the phosphorus back into the bloodstream. So the resorption, the breakdown of bone matrix, the protein fibers and the ground substance. So the osteoclast is like the Pac-Man, and all these little ball vessels are lysosomes. So it's full of lysosomes to digest what's going on. It's huge in what it does. So let me downsize this, and let's go to the osteogenic cells. So it develops into the osteoblast, but we didn't get all the information. So let's add some right here. Let's put it in text form. Let me make this black. And its function, it's unspecialized stem cells derived, meaning comes from mesenchyme. Remember, mesenchyme is connective tissue. And we said it develops into osteoblasts. Now, osteogenic cells are found inside, let's put between. No, I don't want to do that. The inner portion of the periosteum. Inner portion of the periosteum. So that takes us down to osteoblasts. We said that's an immature bone cell. I call it a baby bone cell. And it's formed, it forms the bone extracellular matrix, meaning the collagen fibers and the matrix itself. So it is a bone building cell. It synthesizes and secretes collagen, meaning the extracellular matrix, and it surrounds themselves with that extracellular matrix because it's trapped in their own secretions and they mature into osteocytes. So again, this is the osteoblasts. They haven't moved, still in the inner portion of the periosteum. And we'll just leave it there. All right, that takes us to osteocytes. And osteocytes, we said, is mature bone cells. And they maintain daily metabolism, maintain the bone tissue. So let's put it in the terms that the book uses. Let's put it in green. Maintains daily metabolism. Remember, metabolism keeps us in homeostasis, and catabolism breaks down worn out cells, and anabolism puts new cells together. So it maintains the health of the cell by adding nutrients and taking away waste. And this osteocyte is found in the lacunae. Now, we don't know what those are. Found in the lacunae. And lacunae actually means little lakes. So they're little spaces that the osteocytes are found in. And we'll talk about those shortly. All right, let's go to the next slide. The osteoclasts are the Pac-Man of the bone. That they break down, they resorb using the lysosomes in it. And that allows for growth and maintenance and repair of the bone. And they're found throughout the bone. So let's put that. All right, so let's go to the next slide. This slide here is a picture of what compact bone, that solid bone that we see in the skeleton, that we see on the outside of every bone, is called compact bone. And when we look at it underneath the microscope, we see these round rings of cells. And this whole set of rings, there are several, here's another set, here's another set, here's another set, is made up, it's called an osteon. And it's the functional unit of compact bone, osteon. And every osteon has blood vessels and nerves and lymphatic that runs through the center of it. And we also have blood vessels, nerves, and lymph that go from the periosteum, the outer ridge of the long bone, into the bone all the way to the endosteum. Here's the endosteum. So it runs on a horizontal as well as a vertical. So first, we want to talk about the structure of a bone. And bones have many small spaces in the extracellular matrix that categorized by the density of the space. So we have spaces here and we have spaces here. And depending on the size and the distribution of the space, because this doesn't look the same as this, the regions of the bone are categorized as compact bone here and spongy bone here. 80% of the skeleton, 80% of me is compact bone. And that's for strength and protection. And 20% of my bone is made up of spongy bone. So compact bone is dense, very dense. And it's arranged in concentric units. And we said this already, these concentric units are called osteons. And each osteon has a central canal for blood vessels and nerves and lymph. And that central portion is surrounded by concentric rings. And these concentric rings, each ring is called a lamellae. So right here, concentric lamellae, which is just a ring. All the rings together is an osteon, but each individual ring is called a concentric lamellae. We also said that there are blood vessels and nerves that penetrate through compact bone, and we bring in the blood supply, nerve supply, and lymphatic vessels, and they connect from the periosteum all the way to the medullary cavity. So it goes all the way through. It starts at the periosteum, goes all the way through to the medullary cavity. Let me just make sure we're not missing something. All right, so within the concentric lamellae, and we can see that right here. So let me blow this up. All these little darker dots, if we blow one of those up, it looks like this. And here, this brown portion is the lacunae, the little lake that the osteocyte, this is an osteocyte, lives in. And the canals that we can see, the different canals going from, see these little thread-like regions. Here, so we can see a little better the canals. The canals connect the lacunae, the little lake, to the blood vessels so that nourishment can get to the mature bone cell called osteocyte, the osteocyte. So if we read what it says, these canals called caniculi, caniculi are small channels that connect interstitial fluid that comes out of the blood vessels. And these canal systems provide routes for nutrients and for oxygen to reach the osteocyte that's living in this lacunae, and for the waste of the from the osteocyte to diffuse away from the lacunae and back to the blood vessels. So compact bone, these osteons, all these little ring areas are called osteons, and compact bone are lined up. Notice that they all go lengthwise in this bone because of the stress. So whenever the osteons are produced, they're produced in the direction of the stress. So femurs would be straight up and down, that it is along the line of stress. In compact bone, this compact bone, a solid bone, provides protection, it supplies support, and it resists stress that's produced on the bone by weight and due to movement. Now, each bone cell, each osteocyte, generates a small electrical potential under stress. Now, if you remember, this is not some voodoo thing, but each cell has electrons that spin around it. And those spins create this electrical potential. So every time I pound my leg on the pavement, I shoot out electrical potentials. And that's what helps to keep my bone healthy and thicken my bone to withstand that stress. So what substances give the hardness and what substances give the flexibility? So let's go back to this slide. So let's go to the text. We'll do this slide and then we'll take a break. So this slide says, what substances give bone the hardness? And the hardness comes from hardness comes from calcium phosphate which is an example, one form of crystallized mineral salts. What substance gives it its flexibility? So collagen gives bone its flexibility so the hardness comes from the crystallized mineral salts, which is about 50% of the bone. And collagen is what gives the bone the flexibility. All right, let's take a break and we'll get started again in 10 minutes. So let me stop the video and let's take a break.